The pump was selected correctly. The duty point matches the curve. The vendor approved the selection, and yet, the system keeps failing. Flow is unstable. Seals fail repeatedly. Energy consumption is high. So what's going wrong? Most engineers defend the selection the same way. The pump curve matches. The datasheet checks out. So the pump can't be the problem, right? Here's the unfiltered truth. Pump curves don't operate alone. They assume a system. Every pump curve is tested under controlled conditions. Clean piping, steady flow, ideal assumptions. But real systems are never that clean. The system curve you calculate is almost never the system you actually have. Losses change over time. Valves don't stay in one position. Fouling builds up. Layouts get modified. And as the system curve shifts, the operating point shifts with it. This is how the right pump ends up operating at the wrong point. Even a correctly selected pump becomes problematic when it runs away from its best efficiency point. Efficiency drops. Vibration increases. Seal and bearing life reduces. Nothing in the datasheet warned you about that. Because pump curves are steady state. Real systems are not. Startups, shutdowns, partial load operation, transient conditions. All of these push the pump into regions where it was never meant to operate continuously. This is why replacing the pump rarely solves the problem. The new pump fails the same way. Because the system, not the pump, is unchanged. So instead of blaming the pump, engineers need to look beyond the curve. Check the actual operating point. Check how far the pump is from BEP. Check NPSH margin under real conditions. Check the control strategy. Most problems show up there, not on the curve. Here's the correct order of thinking. Design the system first. Understand losses, variability, and operating range. Then select the pump to match reality. Because your pump isn't a problem. The system is. Subscribe to Engineering Unfiltered for real engineering, no filters.